Everyone, and welcome back for another deep dive. Today, we're going to be trying to get a better understanding of computers using all this awesome research you've given me. You know, it's funny how what we think of as a computer has totally changed.
Right.
It used to be that, like, bulky desktop sitting there.
Yeah.
And now it's like in our pockets, in our homes, and even in our cars.
Yeah, it's everywhere, really. The idea of a computer has evolved so much, hasn't it?
It really has.
And I guess to really get it, we got to start with the basics. Hardware and software.
Okay, so hardware, that's like the physical stuff, right? Like the screen I'm looking at now.
Exactly. The stuff you can touch. The screen, the keyboard, the chips inside.
And the software is more like the instructions, the part you can't really see.
Yeah. It's the brains of the operation, the invisible force that makes it all work.
It's like, without software, even if I had the most powerful computer in the world, it would just be a hunk of...
It would just be a very expensive paperweight.
Yeah.
Yeah.
Just sitting there.
All that potential, but nowhere to go.
Yeah.
And, you know, the software is what we really experience. When you're browsing the web or using an app on your phone,
Right.
That's all software.
That makes total sense. Now, our research talks about these, like, 5 essential ingredients that every computing device needs.
Oh, yeah.
It's like we're going to bake a computer cake or something.
I like that analogy. And you know what? It shows just how diverse computers have become. Those 5 ingredients are input, output, the CPU, main memory, and secondary memory.
Okay, so let's break that down. Input seems pretty simple. That's how we tell the computer what we want it to do, right? Like typing on a keyboard or tapping a screen.
Yeah, anything that gives the computer information from the outside world. Typing, clicking, talking into your microphone, even things like your phone's camera or like a sensor on a self-driving car.
Oh, okay.
That's all input.
So it's not just us directly.
No.
It can get information from the world around it.
Exactly. And, you know, things are getting kind of blurry. Like a touch screen. That's both input and output. You touch it to give information, but it also shows you stuff back.
Ooh, that's a good point. I didn't think about it that way. So output then, that's how the computer responds to us, like showing us the results on the screen or playing music.
Exactly. The screen, speakers, a printer, even a robot arm moving in a factory, those are all examples of output.
Okay, so input, output, got it. We give the computer instructions through input, it shows us the results through output, but what's happening in between? That's where the CPU comes in, right?
Exactly. The CPU, or central processing unit, it's the brain.
Okay.
It processes the input, runs the software instructions, and tells all the other parts what to do.
Now, our source compares it to a brain with neurons and synapses.
Right.
Is that really how it works?
Well, it's a pretty good analogy, actually. The CPU has all these circuits that carry electrical signals, kind of like the neurons in your brain. And those signals, they represent the data and instructions. It's incredible how fast and efficiently CPUs can process all of that.
That brings us to memory. Now, our research talks about 2 types of memory, main memory and secondary memory.
Yes.
So I get that computers need memory to store information, but what's the difference between those 2?
So main memory is also called RAM. Think of it as your computer's short-term memory. It's super fast, so the CPU can access it quickly. The problem is it's temporary. You turn off your computer, poof, everything in RAM is gone.
That's why you got to save your work.
Exactly.
So secondary memory is more like long-term storage then.
It is like your computer's hard drive. It's slower than RAM, but the data stays there, even when the power's off. That's where you keep your files, your photos, all the important stuff.
So RAM is for quick access while the computer's running, and secondary memory is for storing things long-term. But our source mentions that, like, cloud computing is making the lines between these 2 a bit blurry.
Yeah, it is. Cloud storage is interesting, right? Because your data isn't physically on your computer.
Right.
It's on these servers somewhere else, and you access it through the internet. It's a whole new way of thinking about storage.
It really is.
And it definitely adds another layer of complexity.
So we've got the hardware, we give it input, the CPU does its thing, and we get output, all with the help of 2 types of memory. But what about software? We've only talked about it briefly. Where does it fit into all of this?
Oh, software is essential. It's what brings the hardware to life. Without software, those 5 components we talked about, they're just inert pieces. Software gives them purpose.
Yeah.
It tells the CPU what to do and allows us to, actually use the computer.
Okay, so software is a pretty big deal then.
It really is.
What are the different types of software, and how do they all work together?
It's like layers, right? Each with its own specific job. Our source talks about 3 main categories: operating systems, compilers, and applications.
That sounds like a whole other world to explore.
It is. each layer building on the one before.
It's pretty amazing how it all comes together, you know?
Yeah.
Like all those layers of hardware and software working together to create like the seamless experience we have on our devices.
Yeah, right.
Absolutely. We've talked about like all those essential ingredients, input, output, CPU, memory, and now we're getting into software. But I'm having trouble picturing it all working together.
Okay.
Can we use a real-world example to see how these concepts play out?
Sure, absolutely. Let's take a smartphone. Most of us use them every day, right? And it's a great example of how all those components work together.
Okay.
So imagine you're taking a picture.
Okay, I'm taking a picture with my phone. What's happening inside?
Okay, so first you're using the camera. That's the input. It captures the light and turns it into digital data.
Right, so the camera is feeding information into the phone.
Exactly. And that data goes to the CPU, the brain, which processes it, using algorithms to adjust, like brightness and focus. Maybe even apply some filters if you have them set up.
So the CPU's working to make the picture look good.
Exactly. And while that's happening, the image data is temporarily stored in RAM, the phone's main memory.
Okay.
So the CPU can access it quickly.
Ah, so RAM's like the CPU's workspace.
Yeah, exactly. Then, once the CPU's done, the image gets saved to your phone's internal storage, which is the secondary memory.
Okay.
That's where it's kept for the long term.
Gotcha. So we've got the input from the camera, processing by the CPU, temporary storage in RAM, and then finally long-term storage in secondary memory.
Yeah.
But how do we control all of that? That's where the software layers come in, right?
Absolutely. The operating system, whether it's like Android or iOS, it's like the conductor of an orchestra.
Okay.
It manages all the hardware resources and provides that interface you interact with, like the home screen, the apps, the settings, all that.
So the operating system is like the bridge between us and the hardware. We don't have to like speak the computer's language. We can just tap and swipe.
Exactly. And underneath that, we have the compiler. Think of it like a translator between human-readable code and the binary language that the CPU understands.
Okay.
It takes the code for those apps and turns it into instructions for the CPU.
Wow. So even though we just see a simple camera app on our screen, there's this whole world of hardware and software working together.
It's pretty remarkable, isn't it? All that complexity just to take a picture.
And it all fits in our pocket. Now, our source mentions that computing devices are becoming more and more diverse.
Right.
We talked about smartphones, but they also mention like refrigerators that make grocery lists and cars that drive themselves.
Yeah.
How do these devices fit into our understanding of computers?
Yeah, it's a great question. You know, it highlights how the definition of a computer is always evolving. We used to think of computers as just desktops and laptops.
Right.
But now, computational power is everywhere. Think about that self-driving car.
Okay.
It has cameras and sensors that gather information about its surroundings. That's the input.
So the input for a self-driving car is more complex than just a keyboard or a touchscreen.
Exactly. It's getting information from the real world, not just from the user.
Yeah.
And then a powerful CPU processes all that data using algorithms to figure out, how to steer, accelerate, brake.
So it's making decisions based on the input.
Right.
That sounds a lot like how we think as humans.
It does, yeah. And the car's actions, like turning the wheel, applying the brakes, that's the output.
So even though a car doesn't look like a traditional computer,
Yeah.
it still has those same essential ingredients. Input, output, CPU, memory.
You got it.
Okay.
And all those smart devices, they're becoming more connected through the Internet of Things, creating this like network of intelligent machines.
Wow, that's a whole other level of complexity. We touched on compilers earlier, and I had a question about that.
Okay.
Our source mentioned programmers used to write code directly in binary.
Oh, yeah.
How did they even do that? It seems impossibly difficult.
It was. Imagine converting every single instruction into ones and zeros. It took incredible patience. Early programmers were like pioneers, really.
It must have been so frustrating to try and debug code written in binary.
Oh, absolutely, which is why compilers were so important. They automated that translation process.
Right.
So programmers could focus on, the logic and design.
So compilers are like intermediaries then?
Yeah.
Between how humans think and how computers process information?
Precisely. They bridge that gap.
Our source mentions Python as an example of a programming language. I know there are lots of others. What are the key differences between them? And how do programmers choose which one to use?
That's a great question, and it's a whole topic in itself. Programming languages have evolved over time, and each has its own like strengths and weaknesses.
Okay.
Some are great for building websites, others are better for data analysis.
So it's like a toolbox.
Yeah, I like that analogy.
Each language is a different tool for a specific job.
And the choice often depends on the project, the programmer's experience, things like that.
It sounds like choosing the right programming language is really important then.
It is.
We could probably do a whole deep dive just on that, but for now, maybe we should move on.
Yeah, there's a whole universe of fascinating concepts to explore there. We've covered a lot today, from the basics of computers to software to how the idea of a computer is changing.
It really has been a fascinating journey.
And the key takeaway is technology is always evolving, pushing the boundaries.
Before we wrap up, I'd love to hear your thoughts on where we go from here. What does the future of computing look like?
Ooh, that's a big question.
Yeah.
Yeah, it really is a big question. It makes you think about all the people who got us here, From the folks who invented the first computers to the programmers writing the software we use every day.
Yeah. All those brilliant minds working together.
It's really incredible. And it makes you wonder, what's next, right?
Yeah.
What will the future of computing look like?
That's the perfect question to wrap up our deep dive on. Our source gave us a lot to think about, but it also pointed to this really exciting future, like those self-driving cars, those smart fridges.
Right.
It feels like we're just scratching the surface.
Totally. It's like computing is becoming more and more part of our everyday lives. That Internet of Things thing.
Yeah.
It's not just some futuristic idea anymore. It's happening.
Which leads to a really interesting question from our source. If computers are becoming so diverse, what will even count as a computing device in the future?
That's a good one. Will we even think in terms of separate devices anymore? Maybe computing power will just be everywhere, like in our homes, our clothes, even our bodies.
That's kind of mind-blowing. Imagine a world where computing is so integrated, so intuitive that it knows what we need before we even ask.
It's closer than you think. We already have things like voice assistants and smart homes. As technology keeps advancing, it's only going to get more sophisticated.
Well, dear listener, that's about all the time we have for today's deep dive. But I hope this is just the start of your journey into the digital world. You've got a good grasp of how it all works now.
And don't forget, the most important thing is to stay curious. Keep asking questions, keep exploring, and never stop learning.
Great advice. Thank you so much for joining us. And until next time, keep on diving.